Hello, and welcome to the installation and use tutorial for the BCI2000 certification tool. BCI2000 is a software suite for brain-computer interface research. It is commonly used for data acquisition, stimulus presentation, and brain monitoring applications. With BCI2000, you can present visual, auditory, tactile, and other stimuli while recording various biosignals, such as EEG, EKG, data glove, and eye tracking, all in real time. One challenge when assessing responses to computer-generated stimuli is the potential for a discrepancy to arise between the intended stimulus onset and the stimulus presentation. This is due to the processing time required in the operating system, the software application, and the video or sound card. The BCI2000 certification tool solves this issue by calculating the latency in a variety of recording configurations so that it can be accounted for and the limits of your system can be determined. Here you can see an example recording setup for an experiment with visual and auditory stimuli. We can then introduce a triggering device, such as the G-Trig box, to provide a TTL output when an input is provided. We can measure the time when a visual stimulus is presented on the monitor using a photosensor. This sensor is connected to input A of the G-Trig box. Similarly, we can measure the time of the auditory stimulus by connecting the auditory output to low-level input B of the trig box. In addition to measuring the audio and video latency, we can also investigate the data acquisition latency. This might be necessary if you need extremely precise latency measurements, or you suspect your amplifier has a larger data acquisition latency due to the data transfer method, such as a Bluetooth connection. For example, the GUSB amp latency is on the order of 2 milliseconds. Measuring the amplifier latency involves passing the digital output of the amplifier back into an analog input and requires a custom cable. This is described in more detail later in this video and on the BCI2000 certification tool wiki page. The BCI2000 stimulus code designates the time when BCI2000 initiates the presentation of a video, audio, or digital output stimulus. The input time of the amplifier's digital output is measured as an analog input, and the amplifier latency is measured as the difference between these times. Similarly, we can measure the latency of the auditory stimulus and the visual stimulus. Measuring these latencies gives a complete understanding of the system's performance. To certify your setup for video and audio stimulus presentation, you will need a biosignal amplifier, triggering device, photosensor, and 3.5mm audio cable. It's important to connect the hardware correctly to measure the system latency. In this tutorial, we demonstrate the use of both digital and analog input, although using all digital or all analog input is recommended. Connecting the triggered auditory and visual stimuli to the digital input on the amplifier can be done using a standard cable from G-Tech. Here we show the pins that describe this connection. Pin 1 of the trig box is connected to pin 7 of the GUSB amp digital input-output port. Pin 2 of the trig box is connected to pin 2 of the GUSB amp digital input-output port. This represents trig box input A. This pattern follows for pin 3 and trig box input B, and pin 4 is connected to trig box input C. The processing time of the system can be measured by connecting the digital output of the GUSB amp, pin 5, to the first digital input pin. This will not provide a measure of the analog to digital conversion, but will demonstrate the latency to produce digital outputs, which should be very short. Next, we will talk about the analog input. This will require a custom breakout cable. Pin 1 of the trig box output is connected to both the analog ground and reference via safety connectors. Pin 9 is connected to analog input 2. This is because the low amplitude outputs of the trig box start on pin 9. This is still for the trig box input A. Pin 10 connects trig box input B to analog input 3, and pin 11 connects trig box input C to analog input 4. Finally, the amplifier latency can be measured by connecting the digital output of the amplifier at pin 5 to analog input 1. Note the use of a voltage divider. This is needed to reduce the input voltage to an appropriate amplitude for the amplifier's analog input. We designed a custom cable to form all of these connections and demonstrate that the system latency can be evaluated with digital or analog inputs. However, this shouldn't be necessary, Stick to either digital or analog input methods to simplify your certification process. Installing the certification tool will require you to compile BCI2000 from the BCI2000 repository. Follow the BCI2000 installation procedure on the BCI2000 wiki page. To open the certification tool, we're going to navigate to the BCI2000 folder, which houses the various tools. We'll start by opening a file explorer, navigating to the C drive, where I've my BCI2000 repository stored. Here you can see my BCI2000.x64 folder. Within this folder, we can navigate to the Tools subfolder and BCI2000 certification. So to open the BCI2000 certification tester, we'll navigate to this BCI2000 certification tester.exe file. It's an application. That will open this window here. In this window, we can specify a variety of different parameters to vary for our certification tests. What I'm going to go ahead and do is first load an INI file which specifies a variety of tests. So we'll go to File and Open. That brings us to our BCI2000 certification folder, where we can open, for this example, we'll be using a 16-channel GUSB amp. So we'll open the BCI2000 certification 16-channel 100 millisecond block size INI file. So this specifies a variety of different tests in our task list, 60 tests in total. Looking at the first test, we can see it populates some of these various details. The details included are the task name, which is straightforward enough. You can specify a particular signal source, although I'll explain a little bit more about that on the next tab. The signal processing module used in the test, and the application called, the BCI2000 application, which is called. We also will specify the different parameter fragments, which include information about the amplifier source and the task that we're going to be performing. Along the bottom here, we also include the two tabs, the global event configuration, which includes the channels which we will use to certify our device. So we can certify the latency across the analog to digital converter using either an analog channel or a digital input here at the amp stream. We can also specify a channel to monitor the video latency and the audio latency as either a digital or analog input. So in this example, we'll use an analog channel to investigate the ADC latency. So I can remove this amp channel field. For the video latency, we'll use a digital input. So that here I'll specify just digital input 2, because that's the hardware setup that we have here. So we can remove this analog channel field for the video latency. And then in the third field, we'll keep this the same because we'll use an analog channel 3 to measure our audio latency. Here in the per task configuration tab, you can see that certain parameters are specified, like the sampling rate and the corresponding sample block size, which is set in this task to 100 milliseconds approximately. The other important feature that needs to be explained is the BCI2000 state. So the BCI2000 state is records the time at which BCI2000 attempts to present a stimulus. So we'll compare that intended stimulus presentation time to the observed stimulus presentation time in either the video or audio stimulation to determine the response latency and the jitter associated with that. So here for our video state, we'll use the stimulus code, which is the BCI2000 state variable name. And this video state value specifies the location of that stimulus code on the application grid. So that's in a 7x7 grid. That's at the center, which is row 4 and column 4, which in a 7x7 grid is 4 plus 7 equals 11. In tasks that also include an auditory stimulus, such as the stimulus presentation here at the bottom, You can see we also specify an audio state, which is the stimulus code again, and an audio state value of 1. So this is in the configuration tab. There's also the control tab here, where we specify a variety of different global settings. These include the location of the application window. So here this specifies the pixel number where the application window will be located and the size of that window. We can also specify a global signal source, which is probably what you'll need, because you'll probably only be certifying a single device at a time. We can specify a data output directory, which in this case will be in our BCI2000 directory /data and then certification. And of course, the directory where our BCI2000 project is located. In addition, you can specify various command line arguments, and in order to speed up the series of tests, because we're running 60 different BCI2000 tests essentially, we can auto set config, we can auto start the BCI2000 run, and we can auto quit when it's finished. So here, I'll just start the run and we'll start going through our 60 different certification tests. So here you can see we've opened a BCI2000 window. We've started recording with a photo sensor placed over the blinking X in the center of our screen at location 411 that I mentioned before. We're also recording at the signal source. We're using a timing test to measure at the latency across the analog to digital converter at channel 1. So here you can see a run of the stimulus presentation task. We can open View States and Events to investigate digital input 2, as that is where we've specified our visual input. You can see that we have a change in the BCI2000 state at digital input 2. We can also see a change in the auditory channel at analog input 3. We see an increase in response to the auditory stimulus, which is triggered by our trigger box. So once our BCI2000 certification tester has finished running through the 60 certification tests that we wanted to perform, we can actually analyze these results to determine the various latencies for our video stimulus presentation, our audio stimulus presentation, and the latency across the analog to digital converter. So here I have, in the data output directory, I have final results already stored in a certification.final folder. So from here, we can just push Analyze at the bottom. That opens the BCI2000 Certification Analysis tool. And here you can see the results files from all of the 60 certification tests that we performed. If we push Run, we can run through these certification tests to determine the response latencies of our various stimulus presentations. So that opens up the results of our certification analysis, and we'll start here at our highest level folders. This is broken down, the results are broken down into 3 different tabs: requirements, performance statistics, and individual tasks. These each contain roughly the same information, but sorted in different ways to be able to view it effectively. So if we open up the requirements section, here you can see in our run, we've passed all of the various tests. The overall result was that 52 of 60 tests passed, with 8 failing. 48 of our tasks are missing data, but this is because in 48 of our tasks, we didn't actually present auditory stimuli. They were visual stimuli only. And only in the stimulus presentation tasks did we present auditory stimuli. So looking at this, you can see that our requirements for the amp latency is 7 milliseconds. Maybe for the video latency is that the time between when BCI2000 attempts to produce a stimulus and when that stimulus is actually observed by recording with a photo sensor has to be less than 65 milliseconds in our opinion here. So we can look at, within our requirements, it says that we passed overall across our 60 certification tests. we can open this up to look at the results of the individual tests that we performed, right? So we can also look, instead of at the requirements tab, we can sort things according to the performance statistics. So we can look at the individual latency measurements that we were interested in. Again, you can see that there was missing data for the audio presentation latency and the audio latency. This is again because we didn't have auditory presentations for most of our tests. We can look within these nested structures at, say, the video latency again. And again, we can see the various response latencies for these individual tasks. So in the cursor task, at a sampling rate of 1200 samples per second with 16 channels and a 100 millisecond block size, we had a response latency of 51 milliseconds between the intended stimulus presentation time and when the stimulus was observed on the screen. Finally, the results are also broken down by the individual task. So if you're more interested in some tests than others, you can see whether they passed or failed. So in this example, say, let's go down to a stimulus presentation example. These are broken down again into 3 submenus, and in the requirements, this stimulus presentation at 1200 hertz with 4 channels at 100 millisecond block size passed all of our requirements. In an example that failed, so the stimulus presentation AV 1200 samples per second, but with 16 channels instead of 4 channels, we failed to meet our requirements. So it looks like we failed. The audio latency mean was meant to be less than 65 milliseconds, and in this example, it was just at 65 milliseconds. So we just failed this particular test. In addition to simply looking at these statistics, we can observe a visualization, a plot. So let's look at the cursor task, 16 channels. We can go to the requirements. We can visualize this response latency distribution. So if we look at video latency mean, I can click on the video latency and I can right click to plot. This is if you have a GNU plot installed, and this is detailed on the certification tool wiki page. If we push plot, we'll open up this GNU plot where we can see the distribution of response latencies for this task, for the cursor task at 1200 hertz with 16 channels. We can also see this for all of our tasks. So if we go into the requirements tab, say, we can look at the global video latency across all tasks, and we can plot this. We get a much bigger distribution, of course, because we have 60 tests. You can see that in general, the latency between the intended stimulus delivery and the observed stimulus delivery is somewhere on the order of 55 milliseconds. So finally, we can save these results. What we'll do is we'll specify an output directory to store these results in. So for now, I'll just choose our BCI2000 certification tool directory directly. We'll select this folder, and we can push save and view. That saves and opens a text file which details the same results that we've been analyzing here. So this has a summary of the results for across all tests, and then also a breakdown of each individual test, which tests were passed and failed, etc. The current success criteria for various certification tests is defined somewhat arbitrarily. The latencies we chose come from typical hardware setups used in psychophysical experiments. If you want to change the success criteria, you can check the Override Requirements box, shown here, and modify these requirements directly. So for example, if we required a video latency of less than, say, 50 milliseconds, We can change that here, rerun our certification analysis, and view the results of this. So here you can see that overall we fail our video latency requirement if the requirement is 50 milliseconds or less. So this would imply that you need to change either the recording setup or the experiment, or possibly both. Thank you for watching our video.